So in that chapter, our very first topic is impact of jet. I think this part you have already studied in hydraulic machine. Okay, that is impact of jet. We are going to discuss impact of jet. Okay, so if you remember, we have a fixed plate. This is fixed vertical plate. Fixed. This symbol is nothing but the vane is vertical and fixed. It's not moving. Before that, do you know where that impact of jet requires? When in the turbine we have some vane, okay? We have some plate or you can say vane, okay? And after the jet of water comes out from penstock, there is one nozzle. So this is our penstock pipe, this is our nozzle, and then this is jet of water is going to strike the vane or you can say plate, okay? So there are various types of plate and vane, okay? One type is vertical plate which is fixed, okay, which is fixed. So this impact object with the vane is called impact object, okay. So this is our first scenario, okay. When your jet of water strikes a vertical plate which is fixed, okay, then once it strikes, it is assumed that when it strikes in the center of the plate, it assumes that half of the water goes in upward direction and half of the water goes in downward direction, okay. Suppose this is the area of the jet is small a, okay, strikes at the vein at the middle of the plate, and then it assumes that though when it strikes it will be dispersed, okay. So those things are we are neglecting. We are assuming that maximum part of the water, half of it going in upward direction and half of it going downward direction, okay. So this is your vertical plate. Then second condition is, if you see in turbine, this kind of plate is very rare. You can see always a curved plate, fixed curved plate or moving curved plate, okay. So you can draw these diagrams, okay. So this is again penstock. Then we have a nozzle. What is the use of nozzle? To reduce the cross sectional area and increase the velocity of water, okay. So we all know if the same discharge is flowing, if we reduce the cross sectional area, suppose q is equal to area into velocity, okay, area into velocity. To maintain this discharge, if we reduce area, then we have to increase the velocity to get the same discharge. So that is the use of nozzle. We are reducing here the cross sectional area, okay. Discharge is same, and because of this your velocity has increased. So here, that is why we are calling this is as a jet, not water, because it travels at a very high velocity, okay. So in first case it strikes in a vertical plate, and in second case it strikes in a curved plate, okay. So when it strikes in the curved plate also, 50% of water it assume is going upward direction and 50% is going in downward direction, okay. Okay, so this is your axis line, and here it makes an angle theta, okay. When it goes out, here it is more clear, okay. When it goes out, that velocity at outlet, the velocity at outlet makes an angle theta with the axis, that is theta, okay. Suppose this is your moving curve plate. when the velocity of water, this is the axis line, if the jet of water strikes the water, then it goes up. Okay, so if you draw a dotted line, this angle is theta. Or else, if you resolve that component into resolve that velocity into two components in y direction and x direction. Okay, so when you are considering your vertical plate, so you always remember before strike it is in x direction. Your jet is in x direction. If you see, this is your x and this is your y direction. Okay, so before strike it is in x direction, so y is equal to 0 before strike. After strike, if you see, your one portion is goes up and one portion is goes down. Okay, so both the direction is in y only. Okay, it is in y direction. Okay, so x is equal to 0. Okay, for vertical plate. When you consider a curved plate, before that it is in x direction and y is equal to 0, similar to your previous one. Okay, but after strikes, when it moves out, it makes an angle theta with the vertical axis. So if you have to resolve into two components, one is in x component, that is v cos theta. This is simple mathematics. I think all of you know, when you resolve into two component, the member near to the theta is cos theta. Okay, and is opposite in is sin theta. Okay, I think it's very much familiar to you. Okay, if this is the velocity component, if you resolve into two component, one will be your cos theta and one will be sin theta. The member directly adjacent with the theta, that is your cos, and other member is sin theta. Always remember. Okay, it is mathematically proof. Okay, this is a very shortcut to remember, that's why I'm telling you, but this is not the case. This is mathematically proof. Okay, yeah, always that member which is connected with the theta is cos theta and other member is sin theta. Okay, so we have to resolve into two components. So definitely after strike, we have both the components x and y in curved plate. Okay. In vertical plate, before strike, we have a x component because your jet of water is in x direction and y is 0. We don't have any component in y direction. After strike, it is in y direction. Your jet of flow is in y direction and your x direction is 0. We don't have any component in x direction. In vertical plate. Okay, when you come up with the this thing curved plate, you have before strike you have x component, your jet of water is in x direction, we don't have any y component. Okay, after strike, if you see, the velocity component makes an angle theta with the vertical axis. Okay, and then you have to resolve into two component. As you resolving, so you will get both the direction component after strike, that is x and y direction. Okay, now what is the difference between fixed and moving vane? Okay, so in fixed, when your initial velocity is v before strike and after strikes when it's going out, we are considering the same velocity v only. Okay, here also is v, neglecting the friction. Okay, losses, neglecting the friction losses. You all know when it strikes, it lost some energy, and then when it moves out, there is a huge friction will be going out. So this velocity and this velocity practically cannot be same. Okay. So theoretically, we are considering both the velocity is same. This before strike and after strike. Okay. This is just an assumption. Whereas this is in fixed curve. Okay. When you whereas your moving plate, what happened? Before strike, your velocity is v. As soon as your jet of water strikes the vane is also moving at a velocity of u. Okay. In previous case, it was fixed. So your vane or plate is not moving. Okay. Here what happened? As soon as your jet of water strikes the plate is also moving at a velocity of u. Okay, u meter per second. So that is why your resultant velocity which is going out is v minus u. That is your resultant velocity which is going out. Okay, and other things are very much similar to your fixed plate, means makes an angle of theta with the x-axis. So that is why here v minus u cos theta, here v minus u sin theta. Everything is same. Okay, so you draw all the three diagrams. Over. Over. Okay. Okay. So our main aim when we are talking about impact of jet, our main intention to find out f of x and f of y. Okay. What is f of x and f of y? We'll discuss now. Okay. So these are the three scenario, and we need to find out f of x and f of y. Okay. Whenever we are going to solve numericals related to impact of jet, our main intention is to find out f of x and f of y. Okay. Okay. So what is f of x or f of y? That is force exerted by the jet in the x and y direction. Okay. If we consider f of x, that is force exerted by the jet in x direction, and similarly for or in y direction. Okay. Or else you can also say that f of x is nothing but your rate of change of momentum. Rate of change of momentum. Okay. Rate of change of momentum. So what does it mean? Rate of change of momentum. Momentum is, we all know, mass into velocity. So initial momentum minus final momentum. This is change in momentum. And when we are saying that rate of change of momentum, that means we have to divide by time. Okay. Initial momentum minus final momentum divided by time is nothing but your rate of change of momentum. Okay. So now momentum, we know mass into velocity. Momentum is mass into velocity. Okay. So initial momentum will be your mass into initial velocity. Okay. Minus mass into final velocity divided by time. Okay. Done. Again, uh, f of x is nothing but rate of change of momentum. What is rate of change of momentum? Initial momentum minus final momentum divided by time. Okay. Final momentum divided by time. Okay. Then we have initial momentum. Momentum is mass into velocity. As we are considering initial momentum, so we have taken initial velocity, mass into initial velocity, minus then mass into final velocity divided by time. Okay. So we can take mass as common, then initial velocity minus final velocity divided by time. You can write it down. Okay. Mass we have taken common. So initial velocity minus final velocity divided by time. Now this is mass by time. If you see, we have a term called mass by time. Okay. So density equal to mass per volume. If you remember, density equal to mass per volume. So mass equal to density multiplied by this is volume. Okay. Density multiplied by volume. Density equal to mass per volume. So mass is equal to density into volume. Okay. Volume, what is the unit of volume is meter cube. Okay. Unit of volume is meter cube. Okay. So what we have here, mass per time. Okay. Mass per time. So mass by time, you can write it down. Mass by time, you can write it down rho into meter cube per time, or you can say volume per time. Okay. Understood? Mass per time, you can write rho into volume per time. Okay. What is the unit of volume is meter cube and divided by time. Time you can consider second. Okay. So here density will be there. Density rho. Area. Okay. What is the unit of area is meter square. Okay. But we have volume. That means 1 meter is left out. And then time is there. Meter per time is your velocity. So in place of your mass per time, you can write density multiplied by area multiplied by velocity. Okay, rho AV. In place of mass per time, you can write rho AV. That is density multiplied by area into velocity. Okay, any doubts? Clear? Initial velocity and final velocity will be remain as it is. Okay, only in place of mass per time you can write rho AV. That is density multiplied by area into velocity. Okay. How you got this? Density equal to mass per volume. So mass equal to density into volume. Volume is nothing but our meter cube. Okay. So here we have mass per time. So mass divided by time. So you have to divide time. Okay. In place of mass, you can write density into volume or meter cube divided by time. Okay. So meter cube, that means you can write in this way: area multiplied by velocity. Velocity is meter per second and area is meter square. If you resolve again, you will get meter cube per time. Okay. So in place of mass per time, you can write rho AV, that is density multiplied by area into velocity. Okay. Rho AV, and then this term will left as it is, that initial velocity minus final velocity. Okay. So now if we apply f of x for the first case, so rho AV will be there. Okay. Rho AV will be there. Then we have initial velocity. So initial velocity is our, as we are discussing or calculating for f of x, so our initial velocity is in x direction. Okay. Initial velocity is in direction, in x direction, and what is the velocity that we consider as v. Okay. First case. Okay. We consider initial velocity is v. Okay. Before strike, and it is in x direction. Okay. It's flowing in this direction, so it is in x direction. So here rho AV, that is, this is nothing but your mass per time. Okay. Rho AV. And here what we have to find? Initial velocity minus final velocity. So initial velocity in first case, we consider v is the velocity and it is in x direction. Okay. Minus final velocity. Okay. So final velocity in x direction we have 0. So if you use f of x for this condition is equal to rho AV. Okay, then initial velocity will be v in x direction minus, okay, minus then final velocity. Okay. So final velocity we don't have in x direction. Okay. So it's 0. Okay. So after strike we don't have any x component. So this is will be your rho a v square. Okay. This will be your rho v. Okay. So if you apply that f of x for the second condition, will be your f of x, okay, rho a v. Then we have initial velocity. Okay. So initial velocity is v in x direction. Okay. Minus. Okay. Minus then final velocity in x direction. So we have resolved into two components. One is v cos theta, one is v sin theta. So as we are considering x direction, so we have to consider v cos theta because your v cos theta is in x direction. Okay. So v cos theta. Okay. So now as your v initial velocity is in x direction and in this way, and we consider it to be positive, okay, but your v cos theta is in opposite direction, okay. If you consider this direction is positive, so we consider this is negative, okay, understood. So as we consider in x direction, if this direction is positive, so if reverse one will be negative, so that is why we consider one negative here, minus v cos theta, okay. So this will be your f of x. If you consider f of y is equal to rho a v. So before strike, initial velocity in y direction is 0. We don't have any y direction component before strike. After strike, we have v sin theta. Okay, v sin theta, v sin theta. Okay, and it's in upper direction. We have considered this is positive. Okay, if it is in downward direction, we will consider negative. Okay, as your v sin theta is in upward direction, so it will be positive. So this thing will be minus rho a v square sin theta. Okay, this is f of y. Okay, very simple. You can see here. Okay, this is for your curved plate f of x. Okay, rho a v, that initial velocity is v minus v cos theta. Okay, so minus minus you can consider positive. If you bring it out v square, this is nothing but your simplification. Okay, and then f of y rho a v, we don't have any x y component in before strike, so that is why it's 0, and after strike it is in x y direction is v sin theta. Okay, here minus rho a v square sin theta, this is f of y. Okay, so in this way you can also find out for moving plate also. Okay, only in place of v you have to write v minus u. Okay, that's it. Only v in place of v you have to write v minus u. Okay, okay. So those situations are whatever we discuss. It is when your jet of water strikes in the middle of the vein. Okay. So what happens when your jet of water strikes at the one end of your vein and comes out with the other end of the vein? Okay. So in previous case, whatever we have discussed, in those case, your jet of water strikes at the middle of the plate and one portion goes up, one portion goes down. Okay. This is the scenario. Okay. Another scenario is there in your curved vein. This is only happen in curved vein only. Okay, when you have a curved plate or vein, the jet of water strikes at one end of the plate and comes out with the another end of the plate. Okay, so in those case what happen, when it strikes at one end, it makes an angle with the x-axis. Okay, with the x-axis, and again we have to resolve into two components, one is cos theta, one is sin theta, and similarly when it goes out, it again makes an angle with the x-axis. Again this will be your cos theta and sin theta. Okay, so if you consider that f of x rho a v will be same initial velocity, that is before strike, in x direction it will be v cos theta. Okay, so that is why v cos theta minus, again it is in opposite direction, so it is why minus v cos theta. Okay, so it's very similar. If you understand the first scenario, the other things are also very simple, you can understand. Only you have to resolve into two components, one is x and one is y direction. Okay, as we solve numericals, you can understand. Okay, If it is symmetric, do you understand that symmetric means if you take a x-axis, both the portion is same, okay, equally divided, okay. If this is the vein about x-axis, then it is not symmetric. It is called unsymmetric. If it is unsymmetric, your these two angle will be different. Okay. If one is theta, then other one will be phi. That is the only difference. Okay. We have to resolve into two component. If it strikes at theta, okay, here's the velocity, then v cos theta here, v cos theta, then here is v sin theta. So when it goes out, it makes an angle phi. Okay. If it is symmetric, then it makes angle same, both the angle theta. Okay, both the angle is theta. If it is unsymmetric, then one angle is theta, another angle is phi. Okay, that is the only difference. Other things are same. Okay, then we solve some numericals, then it will be clear to you. Okay, you write down this numerical. Okay, you write down this numerical. Okay, a jet of water, a jet of water of dia 50 mm. Okay, 50 mm moving with a velocity of 40 meter per second, 40 40 meter per second, strikes a curved fixed symmetrical plate at the center. Okay, strikes a curved fixed symmetrical plate at the center. Okay, find the f of x and f of y if the jet is deflected at an angle of 120 degree at the outlet of the curved plate. Okay, what is it? A jet of water of dia 50 mm moving with a velocity of 40 meter per second strikes a curved fixed symmetrical plate at the center. So it strikes at the center and the plate is curved and it's symmetric. Okay. So what we have to do, we have to find f of x and f of y if the jet is deflected at an angle of 120 degree at the outlet of the curved plate. Okay, done. Okay, so we move on to the solution. Okay, okay. So let's first try to understand what is the question. Okay, so what is given? It says there is a curved plate which is symmetric in nature. Okay, that means which is symmetric in nature. We have a curved plate which is symmetric in nature. That means about x-axis it is symmetric. Okay, then it says there is a jet of water of 50 mm dia. 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 50 mm dia 50 mm dia. The diameter of the jet is 50 mm, and the velocity is given 40 meter per second. Okay, so the jet of water coming at a velocity of 40 meter per second. Okay, the jet of water coming at a 40 meter per second velocity. Okay, then it strikes the vein in the middle of the vein. Okay, at the center. It says it strikes at the center. Okay, so we have two options. One is it strikes in the center, and it strikes at the one end. Okay, when it strikes at the center, as soon as it strikes, the water gets deflected at an angle of 120 degree. Deflection angle is nothing but as this is your x-axis, this is your 120 degree. That is your deflection angle. Okay, that means this jet of water strikes and gets deflected by an angle of 120 degree from the x-axis. Okay, so this is again velocity v. Then we have to resolve into two components. One is your x direction and one is your y direction, and this will be your theta. So always remember, this 120 is your deflection angle. This is not the angle theta. This is your angle theta. Okay, people used to make mistake here. Okay, they thought that theta is only deflection angle. So deflection angle is not theta. Theta is the angle made by the velocity with the x-axis. Okay, and deflection angle, at what angle that jet of water deflected from the x-axis. Okay, so this theta is nothing but your 180 minus deflection angle. 180 minus, that is deflection angle, it's given 120 degree, so it is equal to 60 degree. Okay, so here in this question your theta is equal to 60 degree. Okay, so your jet of water 50 mm with a velocity of 40 meter per second, it strikes at the center of the symmetric curved vein, and the jet of water gets deflected at an angle of 120 degree. So theta is equal to 60 degree. Now you have to solve. This will be your v cos theta, and this will be your v sin theta. You have to find out f of x and f of y. Okay, let's start with f of x. Okay, so here I have used directly the formula. You can also do like that. Rho a v, then initial velocity. Okay, that means before strike, what will be your velocity? V. Okay, then after strikes in x direction, if we are considering f of x. Okay, rho a v, initial velocity is v, your, that is your 40 meter per second. Okay, minus what will be in x direction, that is minus v cos theta, minus v cos theta. Okay, so rho density, that you can take 1000 kg per meter cube. Area is, as we know, the jet of diameter is given 50 mm, so pi by 4 d square. Okay, pi by 4 d square. So 50 mm you have to convert into meter. Always remember. Okay, 50 mm is given, as everything is in meter, you have to convert into meter. That is nothing but your 0.05 square. Okay, that is your area. So in place of rho you put 1000, area you put pi by 4, 0.5 square, 0.05 square. Velocity is given 40 meter per second. Okay, then here also 40, this v also 40, cos theta, so cos 60 degree. Okay, to find out this value and see you are getting the same value or not, as 4712.39 Newton. solve this f of x and see you are getting the same value or not. How much you are getting? Okay, almost okay. Fine then. Okay. The unit will be Newton. Okay. When you take kg per meter cube here, kg and in meter, then your unit will be Newton. Okay. Whatever the value you are going to get, it will be in Newton. Okay. So similarly, you kindly find out f of y. Okay. F of y. So f of y is also rho a v. Then initial velocity in x direction, sorry, y direction is 0 minus. Okay. Then we have v sine theta. Okay. Initially, before the strike, we have only x component. We don't have any y component. Okay. So that is why it's 0. So if you further break this, rho a v square minus will be there. Okay. Negative will be there. Sine theta. Okay. So this rho you write 1000. Area I think we have already discussed. Pi by 4 you say okay. That 50 mm we have to convert into meter. Okay. That 50 mm we have to convert into meter. 0. I think 0 only. This is correct. Then 40 square is our velocity. Then sine 60. Okay. And see you are getting this value or not. Minus 2720.69 Newton. When you use calculator, because this 60 is in degree, so it should be in degree mode. Okay. If your calculator is in radian mode and if you type sine 60, your value will be wrong. Okay. So this 60 is in degree. Okay. So whenever you are solving this in calculator, always put your degree mode on. Okay. Getting the same value, minus 2720.69. Okay, fine. Newton. Okay. The unit is Newton. Actually, I thought of taking two class today, but tomorrow I think you people are having your project progress viva. Ah, so that is why will be concluding our lecture today here only. Okay, we will solve some more numericals related to this in the next class. Okay.